The first one is saying the first electron, the first shell has the lowest energy and the first to be filled. The second one is saying the first electron shell or the energy level can hold a maximum of only 2 electrons. Now, when you're drawing that, you base on this, that if this is an electron here, you must put an electron down this side. You don't join them together, that this is an electron like this, electron and electron, not like that. They are always in this kind of a cross, that a plus sign. So when you draw it like that, the first electron occupies there, then another electron occupies down. They are always opposite each other. Okay? So the third one is, Ruth, read for us the third one.
The second electron shell holds a maximum of 8 electrons.
Good.
It can hold less the maximum number, but never beyond the maximum number.
Never beyond the maximum number. Very good. Sean, give us what it means.
It's saying that the meaning is the second electron shell, the L shell, it can hold the maximum of 8 electrons and hold less electrons like before 8, but can't hold more than 8 electrons.
Okay. So this is what it means, that if this is the first shell, this is the second shell, the maximum number of electrons this shell can hold is 8. So if we fill the first one here, electron, another electron, another electron, another electron, those are how many?
4.
4. We add again another electron, another electron, another electron, and then another electron. How many are those?
8.
8. So the maximum number that can be taken by the maximum number of electrons that can be taken by the second shell is 8. The first shell is 2. Okay. Then the fourth.
In the outermost shell,
one person.
in the outermost shell of any atom, the maximum number of electrons possible is 8.
Is 8. Any other electron shell from this takes 8 electrons. The first one can only accommodate 2. The second one accommodates 8. The third one accommodates
8.
Then the fourth
8.
Up to the last shell you can write. That is the maximum number it can hold. Okay?
Yes.
So here they are saying electron shells are numbered 1, 2, 3, O, L, M, N, etc. outwards from the nucleus. All electrons in a given shell have approximately equal energy. All the shells in electrons, all the energy shells of an electron have approximately equal energy. So this energy increases in successive shells outwards. So the energy level increases. What they mean is from this shell, the energy level on the first shell is lower than that of the second shell, is lower than that of the third shell, even that one of the fourth shell. So if the shells are 4, the one in the fourth shell has more energy than the one in the lower shell, isn't it?
Yes.
Okay. So this is what they're saying. The energy increases in successive shells outwards from the nucleus. So if the shell is far from the nucleus, then it has more energy than. So electrons on that shell have more energy than these ones near here. So that's what they are meaning there. So the table below shows arrangement of electrons of the first 20 elements, first 20 first 20 elements. Where do you find those elements? In the periodic
Table.
table. Okay. Good. So the first element is hydrogen, followed by helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Those are the first 10. And their numbers also correspond like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you are not seeing well, that's their number. So if they tell you to write the electronic configuration of hydrogen, its number is here, is 1, isn't it? So if the number is 1, it has only 1 electron. So when you are drawing, if you are writing it, 1. Now, helium is 2, this electronic configuration, EC in short. I'm briefing it like that because now at least we have an idea of what it means. Let me draw a clear table this side. We have the first 10. The first one is hydrogen, lithium, helium, beryllium, come to boron, carbon, nitrogen, oxygen, fluorine, and neon. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. We have missed out 1. There's lithium missing here. Here we have lithium. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if the first one is 2, its electronic structure is 1. If helium is 2, its electronic structure is 2. If lithium is 3, we told you that the first electron shell can accommodate how many?
2.
The first electron shell can accommodate 2. If something is 3, what is its electronic configuration? It becomes 2 to 1. Okay?
Yes.
If something is 4, what is its electronic configuration?
2 to 2.
2 to 2. Very good. It's 2 to 2. 2 to 2, sorry. If something has electronic configuration of 10, what it is? If something has a number or atomic number 10, this atomic number, what is its electronic configuration? 10.
5 to 5.
Yes?
5.
You are serious?
2 to 10.
2 to? If it has atomic
10.
number 10, how do you write its electronic configuration? Remember, you are following the number of shells. If the first shell accommodates 2, the second shell accommodates 8. You see this is 2 plus 1. What do you get? 2 plus 1, you get what? 3. Isn't it the number of lithium?
It's the one.
Then 2 plus 2, you get 4. Isn't it the number of beryllium?
It's the
Yes.
How do you get a number with atomic number 2 to 10? Actually 10. Atomic number 10. If something has atomic number, how do you get its electronic structure? Configuration, I mean.
You subtract 2.
You subtract 2 from it. What does it become?
8.
2 to 8.
Very good. If the first shell has taken 2, we expect the next shell to take 8, isn't it? So that when you add the 2 plus 8, we get
10.
10. If something has electronic structure 20, that is atomic number, what is its electronic configuration?
Two to 8.
2 to 8.
I've written 2 to 8. If you add 2 plus 8, you get 20.
No, 2 to 8.
No.
Give me the correct answer.
18.
2 to
18.
2 to 18. Like this. 2 to 18. When you read these laws up here, did we see any shell holding a maximum number of 18 electrons?
No.
What is the maximum number a shell can hold apart from the first one? 8. So write for me the electronic configuration of an element that has atomic number 20.
Can I 2 to 8
To 8.
and 8 to
8 to
8.
8 to
No. 2 8 8.
288.
Yes.
28822.
Is it 2822 or 2882?
28822.
22.
Yes.
If you add this, does it give us 20?
Let me try.
2 to 2
2 to 2.
and
We don't have
8.
first wait. The maximum number that the first shell can hold is 2. The second one can hold 8. The third one 8 8 up to the last. If something has atomic number 20, they ask for its electronic structure. It is 2. 2 is correct. 8 is correct. 8 is correct. Now, what is missing to make this thing 20?
Can I try?
Yes.
Wow.
Yes? Somebody wants to try. Who is that?
Ruth.
Yes, Ruth.
2 to 8.
2 to 8.
8 to 8.
8 to 8, yes. 2
2
2
to
to 2.
to 2. Correct. So if you add 2 plus 8, you get 10. Another 2 plus 8, you get 10. So 10 plus 10 gives us our number 20. Okay? Now, if they say something has a number to actually 19, this atomic number is 19. This atomic number. What is its electronic configuration? Yes.
Repeat the question.
Yes.
Repeat the question.
If something has atomic number 19, what is its electronic configuration?
Two to
2 to
2 to 8 to 8 again to 1.
to 1. That is the correct electronic configuration. Who has not got the ways of writing the electronic configuration? We have all understood how to come up with electronic configurations.
Yes.
Very good. Now, if I give you this, that the first 20 elements in the periodic table, first 20, can you draw their electronic structures? No, the electronic configuration. The first one, the first element in the periodic table is hydrogen. Its electronic structure is 1. This is 1. Let me write them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so those are the first 10. If hydrogen is 1, that is electronic structure, electronic configuration is C. Now, if this one is 2, the maximum number that can be filled with the first electron is 2. So these 2 can be accommodated by the first 2. So this is helium. Lithium is 3. 3, if you put 2 here, how many are missing to make 3?
1.
1.
1.
1,
If this one is 4, it is 2 to
2.
2 to 2,
2 to 2. Okay. If this is 5, what is the electronic configuration? 2 to what?
2 to
No.
2 to 2 to 1.
2 to 3,
2 to 3.
2
Okay.
to 3,
Very good. If something is 6, the electronic configuration is 2.
2 to 4,
2 to 4. If something has 7, what is it? 2 to
5,
2 to 5. Okay. Oxygen is 8, which is 2 to
6.
2 to 6.
6,
Fluorine is 2 to 9.
7,
7.
2 to 7. Then now, neon has 2 to
8.
2 to 8.
8,
Meaning our first shell, the first shell got over from here, it got full. Now the second shell is also full. You get it? It's also full, it's 2 to 8. Now when you go back to other elements, like sodium is number 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The element here is sodium, followed by magnesium, followed by what? Aluminium, followed by zinc. Huh? Here is calcium. This is potassium. This is let me give you this. So let's follow this a little here. Sodium, magnesium, aluminium. Then you have silicon. Sorry, silicon. Then we have phosphorus, isn't it? Then we have
Yes.
sulfur. Then we have chlorine. And then we have 18 is what? Argon.
Argon.
Very good. So if something is 11, its electronic structure is 2 to 8 to
9,
2 to 8 to
1.
1.
And
This is 2 to 8 to 2, 2 to 8 to 3, 2 to 8 to 4, 2 to 8 to 5, and 2 to 8 to 6, 2 to 8 to 7, 2 to 8 to 8. Now, meaning these ones are full. What do you do to get the one of potassium? It is another 2 to 8, another 8, then 1, isn't it?
Yes.
So this is 2 to 8 to 8 to 2. Have you seen where
2
calcium
to
is?
8,
yes.
So that is how you name, how you write those electronic configurations. Okay. Now, when
Sure.
you come,
What?
yes. Someone has a question?
I'm saying we want to copy a table.
You want to copy the table, this one?
Mm,
There is no need of copying this. If you have understood how to derive it, I don't see the reason as why you should copy. Is it there? The table is there. The table is there. Somebody can take a screenshot, what, then you write later on. Okay. So that is the table of electronic configuration. Now, I want us to look at the structure also, so that we draw the things once. Okay. So when it comes to the structure, please take screenshots to be fast. You will get time and look at them. When it comes to the structure, we said electronic structure shows us the position or where these things are located in the shell, isn't it?
Yes.
Now, if we draw the one of hydrogen is 1. It is 1 here. Now, if it is 1, we can draw the nucleus like this. And then we put that electron 1. It can be up here. Just show with an X or anything with O, or somebody can use a dot like that. So in simple terms, for us, we are going to use X to show that value. This one shows that hydrogen has only 1 electron. Okay? Is that clear?
Yes.
The one of helium is 2. So electronic structure of helium is drawn like this. Now I want to remove the nucleus. This time I showed you where the nucleus is. This is the nucleus, isn't it? I'm not going to draw the nucleus again. It's like wasting time. So I'm only going to draw the electron shell here. And I show the 2x, one here and then 1 down. The first shell is full now at this point. When you come to helium, the first shell here is full. Okay. Now, when you come to lithium, now look at the number of lithium. It is a 3. 1, 2, 1, 2. These are how many shells?
2 shells.
There are 2 shells. So instead, the number that you have here, 2 to 1, gives us the number of shells that substance has. So now this one shows that these are 2 shells. This is a first shell. This is a second shell. This first shell was being filled by 2 electrons. Now this one, the second shell is giving us how many electrons are there on the outer shell is only 1. So you indicate here 1. So lithium, this is the structure of lithium. Okay, this is the way it looks like. This is the first 2 because they are full. Then you come to that one. If they tell you to draw the one of calcium here, Ca, which is 20, his electronic structure is 2 to 8 to 8 to 2. These are how many shells?
4 shells.
They are 4 shells. So you draw 4 shells starting from this one. You say 1, 2, 3, 4. Then you fill them. The first one takes 2, 1, 2. This one is over. The next one is 8, 1, 2, 3, 4, 5, 6, 7, and 8. Those are 8. Then again, you draw another 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, this is how it looks like. Now, you have other 2 remaining. So those 2, you start with 1 and 2. That is the structure of calcium. So this one shows that this is 2 to 8 to 8 to 2. Okay. Now, if there are supposed to be 8 electrons on the second shell, this is the second shell, these are 2. If there are supposed to be 8, this is the rule you're supposed to follow. You are not supposed to first fill maybe this one and then add another one here like this. You add one, let me use the red pen, add this one here like this. This is already a wrong statement. You are supposed to first fill the first